Hello, and thank you for joining our webinar today, Data Pipeline Planning and Best Practices. So in a world where data is king, being able to access and effectively analyze information is crucial for leveraging your organization's data to stay ahead of the game. And that's where data pipelines come in. And that's what we're going to be talking about today. And so I have Andrew Brust, and he's the founder and CEO of Blue Badge Insights. And he's here with GigaOm, which is one of our partners. It's a leading research firm. And then we also have Durga here with us, and she is in our data organization here in Pluralsight. And we're going to be talking about data pipelines, best practices, and how it can help you and help you stay ahead of the game. So how are you doing today, folks?
Doing well.
Doing good.
Yeah, I can give you a little more background just because just for context, I'm a former developer and consulting entrepreneur. I've been sort of in the data game. It depends how you count, but really going all the way back to the 80s if you want to get back to desktop databases and back to the late 90s for analytics and business intelligence. In addition to this stuff, I work on with GigaOm. I also write about data and analytics for both VentureBeat and the new Stack. And in fact, had an interview this morning with a key person in the data pipeline game. And I can talk more about that as we get into it.
Awesome. And Durga?
And I am Durga Halaharvi. I lead the data product organization at Pluralsight. So essentially, my team works cross-functionally across the data engineering, and at Pluralsight, we have data engineering for batch separate from stream processing. And so my team essentially leads the prioritization, stakeholder engagement to essentially understand data requirements and needs for model data across, process data as well as data science and machine learning.
That is awesome. So today we're going to be talking with these two folks, and we encourage you all to use the chat feature at the bottom of your screen. And there'll be time for Q&A in the final 10 to 15 minutes of the webinar. So go ahead and ask questions throughout as they come to mind, and we will present those questions to our two experts here. And if we don't get to all the questions today, we'll prepare a Q&A doc after the event, and we'll send that out to everybody who's viewing this webinar. And this is being recorded also, and so we'll be making that available later. So let's go ahead and dive right in. So I'll start off with a question for either of you, whoever wants to. What is big data, and what's driving organizations to build data pipelines?
I guess I can take that. By the way, I neglected to point out one important thing, which is that I'm also a Pluralsight author and have several courses on big data. The term big data actually by this point is getting to be a tiny bit dated. We kind of knew that would happen. We knew we would just take the term big data and refer to it as data, which kind of conveys the point. Most businesses at this point run on data, and because businesses do their work in so many contexts, there's data all over the place. So it's not just that the data volumes are big, which is what big data refers to. It refers to data volumes that perhaps go into the range of a petabyte, which is 1,000 terabytes or more. Again, all those terms get dated and changed, but the number of data sources at this point has just completely skyrocketed is the wrong word, but it has fragmented. There are so many places to get data because so many applications, many of them hosted in not the cloud, but in many different clouds, all produce data. And the old days where we had maybe half a dozen systems that we wanted to integrate into a data warehouse, those old days are gone. So big actually has two dimensions to it. It's the volume of data, but it's also the breadth of data. And because that data is so scattered, that is exactly why we need data pipelines. Because if we're trying to put together a comprehensive view of a customer, or in the case of Pluralsight, a learner or an organization that has many learners, all the data about them is distributed. And in order to do good analysis, you need to coordinate that data and put it together. I imagine Durga, being much more hands-on than I am these days, might even have a different vantage point on things, though.
So question for you, Andrew. I know that the data landscape has definitely evolved across many different organizations of how they get data from one place to another, and the kind of integrations across different databases, systems, et cetera. So can you kind of essentially give us an overview of how a data pipeline, differs from the approaches other organizations have used in the past? What's the evolution kind of been like for us to get to where we are with data pipelines?
Sure, and I don't know if we're able to share up those slides that we had, but if so, there's a diagram in there that's germane. But pipeline, at least the way I use it, really covers a whole breadth of different data integration methods and modes, and also different names. If we skip down, I don't know if it's the second slide or the third slide. Keep going. We'll come back to ELT and ETL. Yeah, this is it. Oh, come on back. Here we are.
Okay.
So you can break data pipelines down into a lot of categories. Where it all began was something called ETL, extract, transform, and load. And that was the very kind of conventional scenario where you had data, let's say, from a line of business system, perhaps running on a relational database like Oracle or SQL Server. You probably had a lot of financial and HR data in your ERP system. There may also have been a couple of mainframe systems and maybe even some things running in spreadsheets. And all of that really needed to come together and be harmonized and shaped. We still have exactly the same problem now, but as we've already discussed, the breadth and the scope of that problem has magnified. For that reason, we have other subcategories that have emerged. We can talk in a moment, if you'd like, about the difference and the nuances between ETL and ELT, which reverses the order of the loading and transforming of the data. There's actually a growing number of systems out there that just do the transformation, make the assumption that the data is going to be moved into, let's say, a cloud data warehouse, and then once it's there, then that's where the transformation needs to take place. We had a whole range going back maybe 10 years ago. We had a whole range of so-called self-service data preparation applications and platforms. I always thought that ought to be a feature, and indeed a lot of those companies have now been acquired, most notably by companies like Data Robot and others. And then there's also infrastructure platform as a service, or information platform as a service. And that's really about cloud-based data integration, typically where the sources are also cloud-based. Not that the other four on this slide can't deal with cloud-based sources, but iPaaS is all about kind of doing everything in the cloud, having the source data, the destination data, and the integration itself take place in the cloud. So that's one way to break down data pipeline, broadly speaking. One that's not showing up here that is actually very popular is the do-it-yourself approach, where depending on the culture of the organization, you may have a bunch of developers, and those developers may prefer to create their own scripts, their own code, their own SQL scripts, and kind of bring everything in themselves. Oftentimes that can work well at the beginning. The maintenance of it is a different story, however. Now, Durga, I don't know if I really addressed your question the way you wanted me to, so feel free to attenuate.
Yeah, I think this was a great overview. Like personally, I know I've seen a bit more of a shift from ETL to ELT, and you did cover and touch upon a bit of that. Could you expand a bit more and also cover some of the differences?
Sure. And actually, could we go backward one slide?
Yeah.
Yeah, there we go. So, I mean, this whole this whole slide should be caveated with, at the risk of stating the obvious, we have ETL on the top, we have ELT on the bottom. And well, as you can see, the major difference is that the transform step moves from the middle to the end. There's more to it than that, though. But in the heyday of ETL, what made a lot of sense was to have a separate platform and frankly a separate server. And we weren't talking in those days about, clusters of servers. So we had a big server for our database, for a relational database. And it was a kind of innovative idea then to say, let's have a separate server for doing the data transformation. Let's also have a separate platform that understands a lot of the primitives involved in data transformation and data movement. So first of all, the idea of having a source table or file and a destination table or file, and simply mapping the columns from one to the columns in the other. But then typically it's not so simple as a straight copy. So you're going to have lots of transformation you want to do. It could be something as simple as breaking up a full name into a first name and a last name. Or vice versa. More likely, it would be something like enriching the data by perhaps bringing in some weather data or bringing in some information about the customer from a CRM system to augment what you know about that customer from the purchase order system. And the idea was, let's have a platform that allows us to either design visually how all those transformations are going to take place, right? Or in a very specialized programming language that is geared to all these different manipulations of text strings and numbers and dates. And that just seemed like a very architecturally enlightened approach. We do the transformation kind of away from the database, so we're not taxing the database with all that work. And then once the transformation is done, then we push it into the database. And in the days of smaller amounts of data, that made complete sense. So we extract it from the source, we do the transformation, then we load it into the target. And logically, that's comfortable for lots of people. And frankly, it depends a little bit on the age and generation, but a lot of people kind of take to that as a default pattern. The problem is that at this point, the data volumes are so large that the notion of having dedicated, a dedicated ETL server to handle it is actually not sufficient. And the idea of not taxing the destination server is less of a concern than it used to be, because now we're in the cloud with the ability to have elastic infrastructure. And if we need to add capacity to deal with the data pipeline and still keep the production processes running smoothly, we're able to do that. Plus, we have the power of the SQL dialect on the destination, which is typically a cloud data warehouse. And so the thinking goes, if we can just get the data out of the source and then load it into the target before we do any transformation, then we can use the capacity, the power, the expressiveness, and the elasticity of the cloud data warehouse to take on the transformation workload. Before, that was something we wanted to avoid because the infrastructure was limited. And in any case, we were just talking about single servers. Now it actually makes a lot more sense to say, let's get the data over there, and then let's go ahead and do the manipulations on it.
Awesome. Thank you so much, Andrew. And just for some context, up at Pluralsight, we have definitely moved into the ELT realm. And, essentially the teams have various tools that they're extracting data from, and they load it directly into the warehouse, which is for us Snowflake, and then perform transformations. What we have started getting into for the data engineering team over the past year is essentially following some Delta Lake architecture principles, where once the data is in a centralized warehouse, there's various kind of quality processing that happens to move the data from like a bronze raw level of quality into gold level quality that other teams like product analytics can use for their business aggregates. So just kind of wondering if you can speak a little bit more to ELT, as well as some of the common, frameworks across like Apache and tooling that is kind of commonly used.
Oh gosh, there are so many frameworks. So, I mean, there are lots that are commonly used, but maybe that's a little bit of a contradiction in terms to say commonly when there's such when there's such a variety. But certainly the cloud providers all have their data pipeline platforms. So in the Microsoft world, it's Azure Data Factory. In the Amazon world, it's Glue, most typically, for two examples. And then kind of when you're not in a cloud specific proprietary solution, we have companies out there like Informatica, which has been around for a long time, but has really completely re-engineered its platform. And we have a number of others. I guess one that's become rather popular lately, and this kind of hits on a theme that I hope we'll get to, which is the notion of whether we code these things or we do these things visually. But there's a platform and a company called DBT that is very popular now, that actually kind of sets up data pipelines in not in a visual, but in a declarative way based on SQL. There's also streaming data platforms that participate though. So for example, Apache Kafka is big in the streaming space and can be used, if you do the stream processing, can be used in effect as a home for where some data transformation pipelining can take place. You have on the visual side, you have vendors like Alteryx, and gosh, there are so many others. We've done whole reports on just nothing but looking at the different pipeline vendors, and we've actually broken that into two reports, one for specialist vendors and the other for enterprise software. Don't forget companies like Cloudera. Don't forget companies like Oracle and so forth. So because this has been a multi-generational puzzle to solve, you have vendors from different generations that are in here too. And with that in mind, I should probably also mention IBM. So there's a ton, and the gold silver, excuse me, the bronze silver gold approach, the Delta Lake architecture that you were mentioning earlier, that too has in a way been around for a while. We just used to have much simpler terms for it. We talked about this notion of staging tables where, the raw data would go in and then we'd run scripts and get that into a more refined form. But then, at least conventionally with data warehouses, you often want the schema or the structure of your database to follow something called a star schema, where you break things up, where you have your metrics data in one place and you have all your categories or dimensions, each in their own tables. So there may need to be some mapping, even once the data is cleansed and deduped and transformed formulaically. You may also then have to change the structure of it from a normalized structure to a denormalized structure. And again, even in the old days, we had that, right? And we were getting raw data from mainframes, and we had to get that into a big enterprise data warehouse. And there were lots of us writing code under an awful lot of pressure, because if that code had bugs, it could be a career limiting factor.
So yeah, great overview. And obviously there's so many, like such a breadth of technologies and tools to choose from. And, going back to what you said of like small scale organizations, they can do custom scripts. And I've definitely seen like a one-man operation where he was just kind of doing command scripts versus like a whole team of data engineers using a mix of, tools like Segment to get the data in, as well as, custom pipeline creation and whatnot. So there's so many to choose from. And, for our, participants across various organizations, there's definitely kind of an overwhelming amount. Like, where do you even begin to, assess what is best for your respective organization?
Well, I was thinking of even one more example, which is in the world of data science. A lot of data scientists do their data pipelines, if you want to call them that, as kind of ad hoc code that they put in notebooks, often written in Python, because they're very motivated. And then transforming it just enough so that they can build a model. So that's a form of pipeline as well. But that's actually a good illustration of a form that can be problematic. It works really well as, when you're doing proof of concept work and you just want to get the data into a shape where you can do a one-off analysis on it. But we have lots of needs where the need to transform the data a certain way and the need to analyze it within some scope of queries that are probably known at the beginning, where that becomes a production process that can't be done as a one-off and can't be ad hoc and needs to run on a regular basis. Oftentimes it might just be daily, but if it's a streaming platform, it could be running continuously. And even if not, it could be running hourly or, several times an hour. And the thing there is that those things have to run, number one. Number two, if there are errors, there has to be manageability around alerting and handling the exceptions and making sure systems don't break down and segregating the bad data so that it can keep moving on and so forth, right? There's lots of common manageability and common exception handling in the world of executing a data platform or executing a data pipeline that has to happen. That's why dedicated pipeline platforms exist, because all of that is already engineered in there. And the notion of developers, in effect, creating that plumbing themselves over and over, when you're in the moment, it doesn't seem so crazy because you really just want to get from point A to point B and have your data in a good form. But as soon as something needs to be a repeatable process, you really need a platform to handle it. And you also need that platform to be able to handle running it at scale, which if you're just running a cell in a notebook, probably won't cut it. There's lots of considerations there. And that's why the standalone platforms are so important and why they don't go away as much as we kind of want to reinvent them and we may want to code it ourselves. The platforms end up being necessary.
Awesome, thank you. And Jeremy, I don't know, I've asked a lot of questions. If you want to jump in, if you had any.
Yeah, you've covered a lot, and some of that stuff kind of resonates with me as a software developer, because for years and years I've dealt with that not invented here type of thing, where it's like, yeah, we have all this off-the-shelf software, but we're developers, we can build it ourselves, and then we start to write custom things and things like that. What is the biggest factor to change that decision? So like when people come to me and say, should we write our own or should we use these tools? I usually have a million questions after that. I can't just say, oh, just write your own, or, there's like a million questions after that. And there's all these different factors that change that decision.
Mm-hmm.
Are there big factors in data that would also change that same decision where they say, well, we can write our own tools and we can write our own stuff. Should we do that? What are some of the factors that come into play when somebody says something like that?
Yeah, I mean, this is just another iteration of the build versus buy question that comes up over and over again in technology. And, the issue is that sometimes off-the-shelf systems don't Either they don't give you all the options and capabilities that you need, or you think that they don't, or you think that they must not be able to. So there is a little bit of ego involved. It also can be fun to write the code, and it can be fun to sort of acquire the experience that comes from writing the code. And I hate to say it, but that's often a factor too, in terms of what developers sometimes choose to take on versus not. Ultimately, though, what you'll find in the world of data transformation is that even though everything seems unique, and even though everything seems to kind of change from scenario to scenario, once you do a bunch of them, you see that there's actually a pretty definable universe of the types of transformations that take place. And so creating a platform rather than ad hoc code just simply makes sense. The platforms, depending on the vendor, the platforms may be many, many years old and have all of that time under their belts for being debugged and troubleshot and being subject and tested at great scale. But what will also happen with developers, and I hinted at this before, is even if it's fun to kind of, or enjoyable or satisfying, fun may sound like a trivial word, but even if it's satisfying, even if it's satisfying to write the code and get it to work and see it working, writing it and maintaining it are two different things, right? And having the responsibility to maintain something that the business is relying upon is ultimately something most developers probably won't be so happy about. So it turns out, as with many things in software development, that there's usually a definable baseline of stuff that can be done either in an automated way or through primitives in a language or through platforms. And then there's always room to innovate on top of that. There's always going to be specialized things that the platforms can't do. And ultimately, that's where developers' contributions are going to be most valuable to the business. And ultimately, those are the problems that are intellectually more satisfying to take on. And so while it may be the case that folks are a little bit territorial about stuff and don't want to have platforms kind of do the work that they might be able to kind of handcraft, it turns out there's plenty to handcraft anyway. So it's not zero sum, and it does make sense to say, let me put as much of this on a but I'll add this as an epilogue, which is that some organizations, the big internet organizations, the companies like LinkedIn and Uber and Twitter and Facebook, first of all, they have such large technology organizations that to engineer something with the same quality as a commercial system is not unheard of. They may also have very special needs around their data simply because they're at this epic scale that even most enterprises aren't. And actually, it turns out a lot of the open source stuff that's out there, began life at these companies and was developed by hand, but with the idea of it being a product, and then it was open sourced, and then a whole community of users and contributors and committers has built up, and that is much more sustainable than just doing something kind of craftsperson-like and doing it bespoke and in-house in a custom fashion.
Awesome. Yeah, that definitely answers it.
And it makes sense, right? If they're going to do all that work, which does seem a little inefficient, then they share that work with the whole wide world, then actually that makes sense, right? Then we're having an efficient application of talent, and there's even a kind of benevolence to it where lots and lots of people benefit. That's where Hadoop came from, which was the kind of nascent big data platform. That's where Apache Spark came from. And by the way, Apache Spark is used either directly and explicitly by lots of folks to do data engineering and data transformation, but it also is the backend engine that's used by a lot of the commercial and cloud-based systems out there too. So Spark has been really helpful, and that didn't come out of a company, that came out of a lab at UC Berkeley, but same principle applies. I'll try and arrest my talking now and see if you have more questions.
Go ahead.
Okay. Go ahead.
Okay. I did want to dive into, so we've covered a breadth of tools and technologies. Did want to touch upon batch versus stream processing. And I know stream processing is very new, it's very shiny, and it can definitely meet a lot of real-time capabilities that teams need, and getting the data to data scientists in a more real-time fashion is always better than not. And from speaking from a product perspective, a lot of the decision making does rest on the actual use cases that are coming through from the organization. But just wanted to get a high level of batch versus stream processing, and any advice and pointers on when to use which within respective organizations.
Yeah, I mean, I would, and this may seem a little disingenuous, but I would start with the idea that if it were just as easy and the same cost to do everything real time, I would say it would make sense to do everything real time. Like, that's the ideal, I guess, is the point, but you can't always go for the ideal. Streaming isn't even that new. If you go back a couple decades, we had these systems called complex event processing, or CEP systems. Those were just streaming systems. Again, the volume of data much smaller. Maybe you're running this on a single server somewhere in a data center rather than a whole cluster of servers in the cloud. But again, all the problems that exist today pretty much existed before, but in miniature. And so our approaches to them were, I think, necessarily more naive. But I have found even with the the aging of streaming systems and the maturity of them that has definitely grown, it's still much harder to do than stuff in batch. Developers understand batch because developers understand databases in SQL. The idea of static data sitting in a table somewhere that you can query and then modify and analyze, that's a pretty well understood rubric. The idea of, well, I'm not looking at a finite table of data, I'm looking at a stream of data, which at any one time the population of is continuously changing. Intellectually, that's different. And unfortunately, in my opinion, the paradigm of working with it, programming wise and otherwise, is different. So you get a kind of mismatch that way. I'd like to see streaming systems and batch systems kind of come together where each one is just really a kind of instance of the other. There's an open source platform called Flink that actually treats everything as streaming. For example, even if it's batch just becomes a special instance of streaming where things are moving more slowly and where the data is more finite and well-defined. So I would just actually like to see it flip around where we can have a kind of abstraction over streaming data that makes it look static. But certainly, if you're dealing with data coming off the web, if you're dealing with data coming from devices and sensors, if you are dealing with, let's say, market data, anything where the data is continuous, and especially if you're doing machine learning / artificial intelligence, the idea of being able to analyze the data without latency, so that you're making your data-driven decisions on the most up-to-date data possible, that's going to be important. And if you're doing machine learning, the problem is that data drifts, and models that may be very accurate when they're trained can become inaccurate. And that can lead to economic difficulties, it can lead to ethical difficulties too, especially if it's a model that's making a decision about eligibility or benefits or making some judgment about the status of a person. You want that model to be as accurate as possible, and that really means you want it to be as up to date as possible. If you are a huge e-commerce concern and you want to be able to offer real-time promotions to customers, then it makes sense that you're going to want the most up-to-date stuff, not yesterday's stats, but the stats that go up to, the last minute or the last 5 minutes, in order to give them something that's really going to be tempting and resonate with them. On the other hand, if you're trying to sort of get a sense of your customer overall, if you're trying to profile somebody, and then it actually probably makes sense to take a step back and say, let me do this based on data that is not old, but has already been that has already landed, has already been stored and scrubbed and probably governed these days, before you go ahead and do analysis on it. So in some cases, it's going to even maybe be preferable to go more slowly. In other cases, it's far preferable to do things immediately. And in still other cases, it's going to be essential to do things immediately. I mean, if I'm allowed to kind of ask questions of my questioners, Durga, I'm wondering kind of how this might come up at Pluralsight. There's some pretty static things about learners, but there's some pretty dynamic things as everybody's kind of looking at courses in real time. And what kind of urgency do you feel around a real-time workload?
Yeah, so the interesting thing, and just for some context, I actually came over from a cloud guru where ACG was actually acquired by Pluralsight. So I actually was exposed to two different styles. At ACG, everything was actually batch. So what you see on the ACG platform, even currently, as we're moving towards integrating it with the overall Pluralsight platform, like all of that, the course data, the backend processing, the way that we store data, that's all batch. And we'd actually been looking at introducing DSML and streaming as something that was on a future roadmap. But coming into Pluralsight, there are definitely, I would say, more real-time capabilities that have been built in primarily to power our recommendation models. So the homepage that you look at on pluralsight.com, if you scroll down a little and see like the course carousel, that that's essentially a recommendation that it's grabbing some behavioral data as you come and visit the website and kind of making some course recommendations to you actively, just, kind of, based off of, if you've searched Pluralsight in the past and search for Python, the next time you visit pluralsight.com, it'll show you like Python courses. And so because there's more of a real-time need and active engagement and more DSML capabilities that have been built in, our front end architecture is kind of a bit more mixed with the data architecture in that everyone kind of publishes their data into Kafka topics. So in that way, the data kind of has this, near real-time capability that it's just kind of constantly cycling the data to better power, user insights and those recommendations.
And is what I said about it being harder, does that resonate, or do you get over a threshold after which it's actually something you can take in stride and it really comes down to skill sets?
Yeah, I think a bit of the latter, where it does come a bit more down to the skill sets, the use cases that we're looking at. But from the DSML team, I've definitely heard that the more than the latency of the data, the quality of the data is really what they're looking for. And so the better quality, even if they have to compromise on latency. So it's not, at the second, it's maybe at an hour or something. They're still willing to kind of take that as long as the user data that they have is reliable and they feel that they can trust the data.
Yeah, so that makes sense. And it's kind of a sliding scale. Like, maybe you don't have ultimate quality. Maybe you don't have ultimate low latency. Is that ultimate if it's low? I don't know. But you're going to have some balance of the two. And as, again, you mentioned quality of the data, I'll also just mention the governance of it, maybe not in the Pluralsight case, but, for healthcare concerns and financial folks, there's going to be data coming in that's PII data. And sometimes it's not always kind of in the known semantics of the data. So you can't say, well, this is going to be PII, but this is just going to be data off a sensor. Well, maybe that data off a sensor gets connected to a customer and tells you where that customer either has clicked or in a different scenario where they've actually walked, right? That is PII. That is personal information that needs to not be misused and not be shared. And being able to determine all that on the fly, we're not quite there yet. You incidentally mentioned one other factor in why the world of data is so different now, which is that mergers and acquisitions. So if everybody's using a variety of sources, imagine what happens when two organizations come together, right? And what this means is the old mentality was, let's get everything in one place. And everything else is kind of an imperfection. And what we've had to do is to say, actually, the distributed nature, the scattered nature of data is not a bug, it's a feature. You may not like it. It definitely makes the problem more complex intellectually. But this notion that you're constantly trying to pull everything into one central repository, that used to work okay, but at this point, you'll just never catch up. So we've had to take a whole different approach to the way systems work. We have all these data virtualization platforms, for example, that make it look like the data is all in one place, but actually physically leave that data in a distributed nature. And that has to happen. One of the big things that brought us into the world of big data is that the granularity of the data used to be transactional granularity. Somebody bought something, or a deal was closed, or a purchase order was issued. Things of that level, and those don't happen with a furious frequency. Number one, they did in the financial markets, but that was always a special case. And we move from having transactional data to having what I call behavioral data, where kind of everything you might do is giving off data exhaust, right? And that, as I said, that could be walking, because all the sensors in your phone are tracking your location and which way you're looking, and even angles and elevations and that sort of thing. Sensors, temperature sensors, light sensors, sensors that are just monitoring the well-running ability of machines on a manufacturing floor. That gets us to the world of continuous data, and that's really what changed everything. So even though I'm a bit of a curmudgeon and I say these problems aren't new, we've always been doing this. To some extent, that's true, but the context has completely changed. The granularity's changed. That means the paradigms have changed and the technology has had to change.
Awesome, thank you.
All right, are we ready for some questions from the audience?
I'm ready if you're ready.
All right, and I have a question here that could be for either of you. What are some of the recent trends in cloud-based data pipelines? Kind of broad, but
it is.
What are the most recent trends?
I will say that one of the tools that Andrew mentioned before, DBT, I've definitely seen a lot more organizations start adopting it now. And tying to another question, but I'm not sure if I'm going to fully answer it, is the analytics versus data engineering, kind of split. DBT has traditionally been an analytics engineering tool because it's focused on getting that, data prepped and processed in a way that it's kind of at the final end of the funnel to, display in a Tableau dashboard or something. But I have seen our data engineering teams kind of adopt the tool more. And then I would say some other items are, going back to Kafka and the, world kind of moving into stream processing and like taking, the Netflix, Spotify realms, as well as, more open source technologies like Apache Flink, which is actually something that our stream processing team is utilizing now at Pluralsight.
Yeah, I also wanted to mention that, I mean, it'll sound like a kind of coy answer, but one of the bigger trends in cloud data pipelining has been the fact that so much of it is moving to the cloud. And that the vendors, even the old vendors. So I mentioned that I met with somebody big in this space today. I met with the CEO, and it was nice to finally have an in-person interview instead of doing it over Zoom. No offense to our Zoom audience, but I met with the CEO of Informatica this morning. And Informatica has been around for decades. They have absolutely been around since the ETL days. In fact, arguably, they created the category of ETL. They have transformed, and there are going to be differing opinions out there on how well, but they have transformed from being an enterprise software company with enterprise agreements where everything ran on premises to, I was told by Amit Walia, the CEO today, they actually, their cloud platform has been written from scratch, not refactored, not ported, not lifted and shifted. They still have their on-prem product. They don't actively sell it, but they have an awful lot of maintenance revenue from it. But most of the action has moved to the cloud. That's where customers want to be. That's where Informatica wants to be. And they've completely moved to a subscription model in terms of how things are monetized. So one of the trends is that even the pre-cloud era vendors have moved to the cloud. And I would make the argument, and this goes not just for Informatica, but companies like Oracle and Microsoft, especially since Microsoft is an enterprise software vendor that's also a cloud provider. There's a lot of snobbery in the industry that says old platforms ought to be rejected out of hand because they're old and therefore they must be obsolete. What I would say is that old vendors, because as I said, a lot of these problems have been around for a long time, and the notion of being able to run stuff without fail for mission critical workloads, the older companies are much more seasoned at that. And if they've been able to take that experience and add it to new technology, then you kind of have the best of both, as opposed to startups that may have very innovative technology, but may not have the experience or the profile of customers to really have been exposed to all of those in the trenches, harsh conditions, and may not have bulletproofed their platforms the same way. Or by the same token, if you're doing open source stuff and running it yourself rather than on a managed platform, and you can run open source in a managed context, I'm not saying you can't, and there's whole companies that are dedicated to offering that. But keep in mind, it's the same sliding scale question, the same balance question as before. Do you want everything to, you want the latency to be zero? Or are you more concerned about quality? Probably you're concerned about both. It's a give and take. The question is kind of where to set the balance. And it's going to be the same thing here in terms of your enterprise readiness and your mission critical readiness of your vendor on the one hand, and the innovativeness of their platform on the other. You don't want something that's stale, but you don't want a vendor that's so green that as soon as you start getting to running this thing under heavy load that it breaks.
Absolutely. So the next question I have here is, how have tools like Databricks changed data pipeline structure or portability? guess that's two separate questions, kind of, but and that one's for either of you.
I'll take it if it's okay, or I'll take it first. Databricks is a really interesting case because the company is founded by the people who created Apache Spark. The platform is built on Apache Spark. And it's very much in that sense, a developer-oriented platform. And, you know, I would say the number one use case for Databricks has been data engineering and data transformation and data pipelines, but in that more kind of bespoke approach that I said can get you into trouble. But the folks who really wanted to code their own have loved Spark and in a lot of cases love Databricks. And so that's been a great source of revenue for them. But even they at this point have now introduced a declarative data pipelining facility as a feature in a Databricks workspace. So I would argue it's a function of maturity. When something's new and really exciting, developers always love stuff that's new and exciting. And I'm a former developer, so I don't mean that in a condescending way. That's the thing about, if you're going to be a good developer, you're constantly keeping up with new things. You kind of like the fire hose effect. If you get stuck with skills that were really marketable last year, but maybe fading, that's not going to be great for your career. So habitually, you're always looking for new and shiny stuff, not because you're vapid or superficial, but because you need to be for the well-being of your own career. And that's why Pluralsight is here, right? So we can constantly help developers upskill and cross-skill and you know, learn whole domains of software that maybe they didn't see themselves getting into before. But ultimately, as things mature and become more mission critical, you start to need more infrastructure and more plumbing built around it. And the DIY stuff really has to move up the stack to what I was talking about before, where you have a baseline platform that takes on more and more and more. And I would just say, avoid the mentality that says this platform is coming to take away my job, because just like you constantly have to learn new skills, you also constantly have to see new use cases where what you did last year is getting commoditized and automated and platformed, but that just lets you get on to the next level of sophistication. We're always going to need developers because we can't have a priori knowledge of everything that has to be kind of systematized, right? Just kind of instantiated in code.
Awesome. And Durga, did you have anything to add to that?
No.
Here's another question that we kind of touched on just a little bit, but with more low code, no code pipeline creation options, what are some concerns around that from your point of view? And that's for either of you or both of you.
Durga, would you like that one, or would you prefer I feel that?
I can take a stab at it. I think, you know, an interesting use case that we have within Pluralsight is that we're trying to get flow data from the Flow platform into, you know, Snowflake. That is essentially our, you know, warehouse for all data across like skills, flow, and cloud, formerly ACG. And so it's been interesting to us because we've used Stitch as a kind of a low code, no code pipeline to ingest the data from, you know, essentially the Flow backend database into Snowflake. But for some of the more specialized, you know, queries and needs, we are definitely leaning towards a bit more of a, you know, custom pipeline, you know, integration that we will probably need to be building out in the data engineering realm. So from a certain perspective, I think like some concerns that I see for low code, no code is it may be able to handle some of the higher level and maybe some broad use cases of just taking data from one place to another, but perhaps getting into some of the specialized use cases, I can see that some of these tools, they might not be able to fit every single, you know, glove.
I couldn't have said it better. And it's again, it's the build versus buy, right? If something's a fairly common domain and has been examined by lots of parties and has become kind of routine and commoditized, then platforms can take that on. But there are new situations emerging all the time, and software vendors are not clairvoyants. There are folks who are trying to, I mean, ultimately what you want to do is have as much centralized engineering that benefits everyone as possible, so that all the individual parties can spend the maximum amount of time working on their unique problems and unique requirements. What happens is, if somebody innovates around a unique requirement and a unique scenario, it may get adopted more broadly and then become more common and then move into the platform. But I see that as a continuum. We're never gonna, there used to be, what was that? There was a commercial for a satellite internet provider of all folks that made the joke that there was this one customer, and he said he read the whole internet. Which of course was absurd. And that's a good metaphor for this, right? We're never going to finish all computation. That would be like discovering all human knowledge and all experience. There's always novel stuff.
So here's another question, and I'll just read it as it is.
Sure.
I've found that few companies actually interpret their data in a way that doesn't represent the truth. They seem to drive to the answer they want. It comes about as they don't understand the constraints of the data as it was created in, so that they infer intelligence outside the boundaries of the data validity. I was wondering what you folks think of that.
I mean, I agree. That's always been a problem. And part of the reason we have augmented analytics and natural language generation and automated insights is so that there can be some automation around analyzing the data, rather than kind of modeling it a certain way and then getting a result that's a self-fulfilling prophecy. One argument that's that has long been made around data visualization is that when you see something in a chart, it looks authoritative, but what you've put on the x-axis and the y-axis could easily be about coincidental correlation and not have any kind of causal links. And yeah, I mean, data's always going to be manipulated, just like information is always going to be manipulated, and misinformation and disinformation has become a huge problem, and technology has enabled it. So I don't think data pipelines are going to fix this. I think a lot of it comes down to, I don't know, intent and goodwill, and probably also careful governance and vetting and validation, which is easy for me to say here, sitting in a chair with a picture of the Empire State Building behind me. But
absolutely. Durga, did you have any thoughts on that?
Yeah, I actually echo what you were saying. And I don't know if you specifically said confirmation bias or like another phrase, but like I didn't.
Yeah, that is the applicable phrase. I didn't use it. Yeah.
Yeah.
Right.
And I mean, at the end of the day, that might not be a data problem necessarily. It's maybe a little bit more on like a people side, and you're going to run into that regardless of what level of data maturity there is just trying to find the answer that you want to find, rather than, being comfortable with uncomfortable truths. So I guess maybe from a product perspective, it's just, as you go about data-driven decision making, like a big thing about data-driven decision making is to debunk some of the assumptions that you had put forward of like, yes, my product will be successful in the marketplace, and really being clear on the questions that you are trying to answer, and setting those KPIs beforehand of this is a specific benchmark or metric that I'm trying to aim for, that says this is a success. If it falls short, it's a failure, things like that. And essentially just being open to that level of just kind of coming to terms with your own data and the questions that you are personally trying to answer.
That confirmation bias, though, will get kind of formalized in machine learning models if you're overfitting to a small amount of training data. So I suppose data pipelines can help there, in that if we're bringing in fresh data and we're doing it with low latency, at least in the world of modeling, we can get beyond a kind of flawed understanding of what the data is. But ultimately, it comes down to ethics and human intent, and vigilance, and some amount of audit and validation.
Awesome. So we are at the top of the hour here, and so I wanted to thank you both for coming today and sharing all this good information. I'm somebody that doesn't know a lot about data, and I feel like I've learned a lot. So
Okay.
I'm pretty excited. I hope the audience feels the same way. Is there any final thoughts or any last things that either of you want to say as we close it down?
Well, I could be self-serving and say watch all my courses, but except that I just did that in the third person, I won't say it. But yeah, I would just say keep your eye on this, watch this space, as one television personality likes to say. The technology is churning all the time. There's tons and tons of VC investment in new startups. Arguably, it's churning maybe more than it should, but it doesn't matter. It is what it is. And some of the most important coping mechanisms can just be to keep up with what all the categories are and what the state of the art is. And then kind of make, I don't know, sober decisions about what it is you want to skill yourself in and adopt in your own organization.
Yeah, and I guess I have a lot of empathy for all of you guys out there with various data needs across the many respective organizations that you work with, and it's definitely a combination of the use cases that the teams need and bring to the table for analytics, combined with the leadership push to put data as a forefront and of all companies. So yeah, thank you all for joining and asking great questions and listening to us.
Yes, thanks very much for having me.
Awesome. Well, thanks both of you for doing this. Thank you for everybody in the audience, and thank you for the great questions. If we have any questions that are in the chat that haven't been answered, I can deliver those to Andrew and Durga, and we can see if we can get those answered for you and sent out to everybody in the group. So
excellent.
Thank you all for attending, and have a great day, everybody.
Thank you.
Thank you all.